So I had a couple of these that a buddy gave to me a while back, and I never knew what they were from. And I started playing with them the other day. I noticed that I could send very little voltage in here to get very high voltage out, depending on the frequency. And I ruined it by trying to pot it, and for some stupid reason I decided to use wood glue, which screwed it all up. But there goes another one. It's from an this is an LCD monitor. So there you go. I want to say wherever this one came from, my buddy swears up and down he got it from a plasma. So if you compare these two, it's kind of hard to tell, but the amount of windings that are actually on this one is significantly more. And the overall size, it's kind of hard to tell. This one is a little beefier. And this one actually came pretty nifty. It just really had the secondary outputs there, and it had the bifilar wrap on the primary over here, and it just made it easy enough to put two of them together and wire it as a jewel thief. But what I did here, obviously, I stupidly used the wood glue. I should have known better. I totally ruined this thing by doing that. I was just trying to pot it. I don't know what the hell I was thinking, but it screwed it up. But this thing was able to kick out really good arcs. And the thing about it is, it ran the best at about 3 kilohertz. But the duty cycle was very low. It wanted about, a 20% duty cycle. And at that point, I was able to drive it from the simple jewel thief rig using a 1K resistor and a trimmer. And that thing was pulling so little power, I really didn't need this heatsink for that transistor. This thing was pulling great arcs, and it was working pretty good down to 2 volts, so long as I drove it from the module. And it really pissed me off that I ruined it. I managed to, I guess, rip off the markings on there also, so I really have no idea where to source that. This one I had going pretty good as well. It took the right ratio of windings on the primary. You're not just able to throw a few wraps on there and there you go. I had to increase the wraps to a point where I got the highest arc, because the name of the game is creating a magnetic field and transferring it. But this one I burned out. It didn't take long. I just put hot glue over it, which was really not going to do a whole lot. I got that thing to go to about a 1.5 centimeter arc before it finally burned out. Unless I'm getting them mixed up, this one preferred a much higher duty cycle to get that, and it wanted a lower frequency. So, they're all different. Depends on the core, all type of stuff, but this one right here, it's a transformer that came from an old school xenon powered strobe light that you use to set your timing in your vehicle. And this is the transformer that was in there to drive the xenon, and it's got a very high turn secondary. That thing was at about 1,000 ohms. When I noticed that, I was like, well crap, let me try pulling some arcs off of it. So hopefully I'm not going to burn it out in this video. I probably will, because I'm trying to just push it to get an idea of what it can handle, because I know where to get another one of these from actually. And I've already slightly arced to it. There's this little black spot here where I had to rip the main lead off because it was arcing, and I was left with the very hair thin wire just barely poked out, and I resoldered it, hot glued it here on this lead to try to save it. So right now I've got this power supply hook turned all the way down. It's actually running to this MOSFET I have in here. That MOSFET is being told to switch according to this module here. It's the gate voltage, somewhere around there works. So we're at 242 hertz, 34% duty cycle. Cut it on. Let's see. It's not going to do anything at 1 volt. See at what point get a little action. Right about there. So now gonna back down the duty cycle one click at a time. You see it's gone out there, about 29, 28, so I'm just gonna back it back up one click at a time now. And this whole angle kind of sucks. So that's actually not anywhere close to what I was getting from this transformer. And at 3 kilohertz, obviously it was also a much smoother arc. But man, that thing was getting some real good distance. But for this being a just a non-potted transformer, they've just sort of separated the windings a little bit. But I'm kind of surprised this thing never arced over. It's, you know, all I did was move that winding or that lead a little bit away from that one spot it wanted to arc, and seemed to handle that pretty good. So that's not too dissimilar from what you can get from a small flyback transformer at that amount of power being driven into it. So this could probably be wound as some type of jewel thief setup, so long as you drive it at low frequency. Alright, so just watch the relationship here. So we're at a good point. 113 hertz, 21% duty cycle, 9 volts or so. We're out. Now the duty cycle is too high. Out. Oddly enough, 50 hertz is too slow for this length of an arc. And over about 150 or so is too fast. So now I'm at 254 hertz, 20% duty cycle, no arc. Let's raise that. So you can see now, at a frequency higher than what it wanted before, at a much lower duty cycle, now we're able to get that light at the higher duty cycle. But that is to say, at roughly 20% duty cycle, there's only a particular frequency range this thing wants to operate in. We already know it's very low, so if you sweep up even higher, it's not going to make a difference. Go all the way up to the inaudible frequencies, which a lot of these high pressure drivers are running at. And so, you know, we're, let's say 27 kilohertz, and see, even if I bring the arc or the distance closer, it's not doing anything. Getting the tiniest little baby, you can't even see it on a camera. So at that point, what happens if I bump the duty cycle? Let's put it at about 64. Now you can just barely see the tiniest little mark there. So let's bring that back to 24, let's say. drop that back down to about 100 hertz or so. And again, to ignore that little pop at 1K, that's the module spiking. So that right there, it's probably going to be around the best bang for the buck as far as power. It's just got an annoying frequency. Very low annoying frequency. But a little too far apart. I can smell that ozone. Alright, this one's not really meant for high voltage. I believe it's some kind of, I honestly cannot remember what this is from. Maybe from some type of power supply. Got the xenon bulb on the secondary. And this is one that had the common center tap. Had a center tap so you could wire it as a blocking oscillator, but I've just got two leads hooked up. And 745 hertz, 61% duty cycle. So I'm just going to shift up and down in the frequency, show what happens to the output. To a degree, you can see the intensity, the amperage actually go up and down. So cut that on. So it's kind of kick started, and it's kick started even brighter now. So I'm going to cycle down a little bit. So I brought the duty cycle down to about 24%. It doesn't want to come on at that voltage. Let's bring it up to about 30, 36 or so. Nope. So let's bring it back up to where it was. Bring it about 60. So we're about 60. Get that thing to come back on. I'm going to sweep down on the frequency. (150 hertz), 91, 77. And I'll go back up. (134), 500, 1K, 5K, 10K. Now we're in the inaudible, and it just fizzled out about 30 kilohertz. I don't know if I'll be able to get it to ignite again at this frequency. Probably not. So it needed the lower frequency to kickstart. I would imagine somewhere closer to 1K. Let's see, 5. Let's try 5. No. Let's go all the way back down to 1K here. Alright, so we're back at 1K. Start it back up. So I'm going to show the intensity of the arc on this bad boy. Alright, now at 1.5 kilohertz, about 60% duty cycle, still about 11 volts. Secondary on here kicks out some serious current. And that is a very hot arc.
wants to weld the wires together as soon as I touch them. That's how I draw the arc though. I can already feel just from those short seconds the wire is incredibly hot. It's getting hard to hold just from this short little arc. But obviously at the point, it's taking so much current at the point where I short it right here, that's when the primary is taking in an insane amount of current. As well as when I draw that arc there, so it's, wow, that's hot. It's costing a lot of energy to do that. Alright, got a pretty standard jewel thief right here. I haven't actually wired this as a jewel thief. I've basically just got the two windings separated. And you could say this is right now just a one-to-one transformer, where this is the primary. I've got this LED on there, and this other LED, the secondary, you could say. Now I'm feeding it 0.8 volts total right now, so that's the voltage feeding into the transistor. And basically right now what's happening is that 0.8 volts is pulsing this coil, and this LED is in reverse. So the positive is hooked to the negative, negative is hooked to the positive. So this LED is being lit from the flyback, the collapse, from not only the primary in this case, but the secondary, you could say. So magnetic field's collapsing in both of these coils, and it's flying back at a higher voltage to light this LED. And the same thing's happening with this coil over here. Typical jewel thief deal, except it's not oscillating itself, it's using this to drive it. And one of these lights is about to burn out. Yep, so that one's gone. Way too much voltage on that guy. But we still got this other one going. We'll crank the duty cycle down there. So let me replace that LED. Alright, so when I add this LED, now it's going to steal some of the flyback. If I can get it in there. So that's kind of in there again. Stealing some of the flyback. Duty cycle was way too high. Voltage was way too high. It burned that bad boy on out. Alright, it took me a while to find it, but right about this point at about 7.8 kilohertz and about 57% duty cycle. Now we're at the point where I can take this capacitor, put it across this LED. It actually increases the amount of flyback going into that first LED. So obviously without these coils being loaded with any LEDs, the voltage would be, open voltage would be a lot higher. But it's being dragged down by these LEDs, so I'm going to try throwing a neon on there, see what happens. So it's kind of hard to see, but now we're at about 2.2 volts, about 3 kilohertz, 50% duty cycle. And the neon, the higher voltage on this neon is essentially being lit from the flyback. Now this coil is completely separate, and while this coil is pulsing and it collapses, it creates a flyback which is induced into this guy right here. Likewise, you do the same thing by putting it on the primary. So now it's on the other side, catching the flyback from the on the primary side from the 2.2 volts. Alright, so I'm back down to under a volt. I've got these blue LEDs on here now because the white ones pretty much burned out before I got a chance to really sweep through here. And let's see, try to cut that down.
So I'm at 10% duty cycle, 45 kilohertz. I'm going to ramp down from there. So at that 45 kilohertz, sweeping down, this is what the other LEDs should have looked like, but they burned out too soon because I had the duty cycle too high. The voltage was way too high. So I'm down in the low frequency, about 200 hertz, and you see we got pretty solid light until I ramp it up. Let's see if I can get it all in the shot here. So if I ramp up the frequency from here, see they start shifting, gear shifting, I guess you could say. So they hit points where they're barely illuminated. There's about 5K. And when I keep going up, so they keep shifting in and out. And there's going to be certain points where they're going to be the brightest. About 50 kilohertz or so. Any higher than that wants to extinguish those LEDs at the duty cycle, at 10% duty cycle.